What if I told you that in just 90 seconds, the internet could go dark across the planet? No warning, no Wi-Fi, no banking apps refreshing, no GPS guiding drivers through traffic, no messages sending, no emergency systems syncing, just silence. Not because of hackers, not because of cyber war, not because of some Hollywood-style EMP attack, but because of something 93 million miles away. The sun. Every second, the sun releases unimaginable energy. Most of it warms our planet, powers our climate, and makes life possible. But sometimes, without notice, it erupts. A violent explosion on its surface can hurl billions of tons of charged plasma into space at millions of miles per hour. Now imagine this. It's a normal Tuesday morning in New York City. Screens glow in high-rise offices. Traders monitor markets in real time. Content creators scroll through TikTok. Airplanes cross the Atlantic guided by satellite navigation. Hospitals sync patient data to cloud servers. Billions of invisible digital signals pulse through fiber optic cables beneath oceans. Everything feels stable, connected, permanent. And then, on the surface of the sun, a massive coronal mass ejection detonates. A magnetic shockwave tears outward into space. Hours later, it collides with Earth's magnetic field. The planet shudders, not physically, but electrically. Satellites begin to glitch. Some lose orientation. GPS timing signals start to drift. Power grids experience sudden surges of induced current. Transformers strain under invisible pressure. Data centers flicker. Routing systems lose synchronization. The global internet backbone, the hidden infrastructure connecting continents, begins to destabilize. Not in flames, not in explosions, but in cascading system failures. Signals drop. Networks desync. Critical nodes disconnect. All unfolding in less than 90 seconds. This isn't science fiction. It's space weather. Scientists at NASA and NOAA monitor solar activity around the clock. Satellites positioned between Earth and the Sun constantly scan for eruptions, tracking flares and magnetic storms before they reach us. Because experts understand something most people don't. A powerful solar storm isn't a question of if. It's a question of when. And when it happens, those 90 seconds could change everything. Let's break this down. What is a solar storm? A solar storm begins with instability on the sun's surface. Magnetic field lines twist, snap, and realign, releasing enormous amounts of the energy. Sometimes that eruption launches a coronal mass ejection, or CME. A massive cloud of superheated plasma threaded with magnetic fields. If that CME is Earth-directed, it can reach us in as little as 15 to 18 hours. And when it arrives, it doesn't hit the ground like a meteor. It collides with something invisible but critical, Earth's magnetic field. That magnetic shield normally protects us from harmful solar radiation. But when a powerful CME slams into it, the interaction can trigger a geomagnetic storm, a planet-scale electrical disturbance that ripples through the upper atmosphere and down into the surface. The real threat? Infrastructure. Here's what most people misunderstand. The internet doesn't float in the cloud. It's physical. It's grounded. It's wired. It runs through thousands of miles of undersea fiber optic cables, GeoWise, satellite constellations orbiting Earth, ground relay stations, massive hyperscale data centers, and most importantly, the gigawire, the global electrical grid. During a severe geomagnetic storm, fluctuating magnetic fields induce electric currents in long conductors. The longer the conductor, the stronger the induced current. That means that high voltage transmission lines are especially vulnerable. These unexpected currents can overheat and permanently damage transformers, trigger protective shutdowns across regional grids, cause voltage instability, disrupt timing systems used by financial networks, At the same time, satellites face radiation exposure and signal distortion. GPS relies on incredibly precise atomic timing. Even microsecond disruptions can cascade through banking systems, stock exchanges, telecommunications routing, and cloud synchronization. Without stable electricity and accurate timing signals, the internet's backbone, its routing systems, data exchanges, and server clusters begins to fracture, not because the cables melt, but because the systems coordinating them lose coherence. This has happened before. In 1859, a powerful geomagnetic storm known as the Carrington Event struck Earth. Telegraph wires sparked. Operators reported electric shocks. Some systems transmitted messages even after being disconnected from their power supplies. Auroras were visible near the equator. That was in a world powered by telegraph lines. Now imagine that same level of solar intensity hitting today's hyper-connected digital civilization, where nearly every essential system depends on uninterrupted electricity and satellite synchronization. The technology is more advanced, but the vulnerability is exponentially greater. Let's fast forward. The storm hits. At first, it feels small. A flicker, a signal delay. A few dropped connections, then the grid begins to strain. In parts of North America and Europe, high voltage transformers overload. Protective systems trigger automatic shutdowns to prevent permanent damage. Entire regions go dark, not because wires are destroyed, but because systems are forced offline. Stock markets freeze mid-trade. ATMs stop responding. Credit card transactions fail at checkout counters. Digital payment systems rely on synchronized timing. When GPS signals distort, financial networks can't validate transactions safely. To prevent corruption, they halt. Hospitals switch to emergency generators. Critical care continues. But scheduling systems, cloud-based records, and remote diagnostics experience disruptions. Air traffic control faces degraded GPS accuracy. Flights reroute. Delays stack up across continents. Container ports pause automated logistics systems. Fuel pipelines relying on electric pumps slow or shut down. Supply chains, already tightly optimized, stall within hours. No cloud servers syncing, no real-time inventory updates, no instant messaging between global offices. The global economy runs on digital infrastructure layered over electricity and satellite timing. Without it, we don't go back to the Stone Age, but we revert decades overnight. The ripple effect financial panic spreads faster than the storm itself. News outlets struggle to broadcast consistently. Social media platforms experience outages. Rumors multiply in the information vacuum. Fuel shortages begin as distribution networks falter. Communication blackouts isolate communities. Businesses close temporarily, unsure when systems will stabilize. Not because civilization ends, but because it pauses. And when interconnected systems pause at a global scale, uncertainty becomes the real threat. But here's the reality. Check. Scientists are not asleep at the wheel. Agencies like the European Space Agency, along with space weather monitoring centers worldwide, continuously track solar activity. Early warning satellites positioned between Earth and the Sun provide critical lead time, often hours before impact. The danger isn't instant extinction. The real risk is infrastructure vulnerability in a world that depends on constant connectivity. Here's the truth. A solar storm powerful enough to disrupt global systems is rare, but it is not impossible. Events on the scale of the Carrington Event are statistically capable of happening again. The sun operates in cycles, and periods of heightened activity increase the likelihood of strong eruptions. The difference today, we are not blind. Governments and grid operators are actively working to reduce vulnerability, hardening power grids against geomagnetic currents, upgrading Baruba for transformer shielding and surge protection, improving early warning detection systems, designing satellites with greater radiation tolerance, running large-scale resilience simulations. Organizations like NASA and global space weather monitoring centers continuously observe solar behavior, providing crucial lead time before storms impact Earth. Technology is evolving. Monitoring systems are more advanced than ever. Preparedness planning is improving year by year. The sun makes life on Earth possible, but it also reminds us of a humbling truth. We are a technological civilization built on delicate, interconnected systems. Awareness is not panic. Preparation is not fear. If a 90-second solar storm ever strikes Earth, it won't end humanity, but it will test our resilience. And the real question isn't, will it happen? The question is, how often will we be ready?